Okay, so let's go ahead and finish up our last two trig functions here. We're going to look at how to sketch graphs of tangent and cotangent functions. Really, if we already know how to do sine and cosines, this is going to be a very similar technique. It is going to be, though, like secants and cosecants, we are going to have undefined values, so we're going to have vertical asymptotes, which makes writing the domain a little bit of a pain and things like that. But to start with, though, we are going to use the same techniques. Now, again, if there's an A out in front of the tangent, we wouldn't call it amplitude because you'll see why when we graph it. But the big difference here, and the thing we have to be aware of, is the period, instead of being 2 pi over b, which it was for the other 4 trig functions, is now just pi over b. And that's significant because if you miss that, if you get the wrong period, you get the wrong values in your table, not a happy day, right? So, as we saw, though, with sines and cosines, and then cosecants and secants, we always ended up taking the trig value at the same angles, correct? They were always just the different, it was like, what, 0 and pi over 2 and pi and 3 pi over 2 and 2 pi. Well, because of this difference in period, here we should always end up taking the same tangent and cotangent for these 5 angles here. 0, pi over 4, pi over 2, 3 pi over 4, and pi. So that should be a consistent thing that we're seeing. Okay, so let's make sure we know what those values are. The tangent of 0, and again, I like to think about a kind of a unit circle, but here we're not going all the way around, we're just looking at these values here, correct? So the tangent is 0, we know tangent is y over x, and that would be 0. That'd be 1, undefined, -1, 0. So that's our first row here. 0, 1, undefined, -1, 0. And as we note, as our angle would increase from 0 to pi over 2, we see that the tangent values are going to get larger and larger, correct? They're actually going to approach infinity. Like if you get up here just to the right of pi over 2, you're going to get a huge tangent, right? Because your y value is going to be really close to 1, and your x value is going to be really close to 0. So that's why we're going to see some curves that go off into space like we did with secant and cosecant. The cotangent values are just going to be the reciprocals of those values because the cotangent are x over y. So while this was a picture for our tangent, for our cotangent, we have undefined, 1, 0, -1, undefined, right? And when we're looking at values around the unit circle, we can think of 0 and undefined as being reciprocals. Okay, that's not always the case, but it is a convenient thing that we can think about when we're doing this trig values based on the unit circle. So here we get undefined, 1, 0, -1, undefined. Okay. Everybody doing okay so far? So hopefully we knew those values. It's nice to know some tangent values, like, not always to have to use the sine over the cosine or use y over x. So our first graph that we're looking at here is f of x equals the tangent of x. These are the values that we want to know. Right? If you look, there's no b value here. Right? There's just 1. So our period is going to be pi divided by 1, which is just pi. We would build our table the same way that we're used to. So we start at 0 because there is no phase shift. Right? If there were a phase shift, you'd start at the phase shift. And then we take the first value, which was 0, plus 1 period to get our final value. Do our averages. So pi over 2, pi over 4, 3 pi over 4. And then we just plug in our values. 0, 1, undefined, -1, 0. I didn't calculate them because they're sitting right there, so I figured we could just look over there. And now let's go ahead and graph this. Again, though, like we did with secant and cosecant, we would like our graph to go from a vertical asymptote to a vertical asymptote. So since we really don't, we're going to have to extend it out a little bit and do some extra points. So just be aware of that when you're labeling your number line. So here's pi over 4, pi over 2, 3 pi over 4, pi. Spoiler, you're going to want a couple extra points on either side, but just take what it is there. And then here we have 1 and -1. So the first thing we do is we just plot what we have, right? We're just plotting our points. So 0, 0, pi over 4, 1, and then pi over 2, undefined, 3 pi over 4, -1, pi 0. So at this point, and students will try this, but if you try to draw a graph at this point, things do not go well. Usually it involves people drawing lines across the vertical asymptote, just kind of a general shape that kind of drifts off into oblivion. So that's not enough points. What we have to do is we do have a full period here, our behavior's repeating. So we could go over our next point will be up here at 1, and then to the right of that will be a vertical asymptote. And then if we go, here we are both at 0, we go to the left, we're down at -1, and then we go to the left again, and we have a vertical asymptote. So from here, we're going to get a much better graph. And what this looks like, as we mentioned before, like as we approach, as the tangent goes from 0 and approaches pi over 2, the tangents just get larger and larger, correct? We said they approach infinity. So that's what's going to happen. They're going to go up to infinity. The same thing happens as we approach, this would be -pi over 2 right here. So the graph will look like that. And this is actually 2 periods of this graph. We've actually drawn 2 periods there. So now that we've done that, let's go ahead and list the domain and range of that graph. And again, most of your tangents, now, you throw a negative in front of the tangent, it'll flip it down so where it'll look like this, right? Or if you have a constant out here, it'll make this number be up higher. So it kind of stretches it out, or a smaller number will make it shorter. If you had a number in here, you could do a phase shift, all the kind of typical things we're used to. The big thing is just that the period is pi divided by b, which is different. So for this graph, our domain, we talked about how to write that in our warm-up, but we're going to state where x is not defined. And if we look, we want to see how far apart those are. So let's see. It would be nice to know where this was at, wouldn't it? So we had pi over 4. This is 2 pi over 4, 3 pi over 4, 4 pi over 4. This would be 5 pi over 4. This would be 6 pi over 4, which we'll call 3 pi over 2. So we can see the distance between the 2 vertical asymptotes is 3 pi over 2, take away pi over 2, right? Final minus initial, or farthest right minus the left one. So we see the period there's pi, which I guess we could have just looked there also. Right? So that means that we're going to write where one of them is at, so I'm just going to pick that one. Say pi over 2 plus k times pi. Again, the first number I would recommend if you're writing it this way is just put any location, right? Any location. You could have used -pi over 2. You could have used 3 pi over 2. Anywhere there's a vertical asymptote plus k times the period. Okay, so then I'm going to go ahead again and say k is contained in the set of integers. Now in terms of range, well, what do you think the range is going to be? It's just all real numbers, right? I mean, repeatedly. Like it just goes and goes and goes. So we'd say that y is contained in this set of real numbers. Okay, so next up, let's just sketch a basic graph for the cotangent of x. Just look at our parent function here. So we're going to set the table up the same way we did before. and we had the values here before as well. So the period would be pi divided by 1, because 1 is the coefficient of x, so that would just be pi. And then we're going to start at 0 since there's no phase shift. We'll go to 1, or go to pi, because that is 0 plus pi is just pi. So we'll break these in half again. Pi over 2, pi over 4, 3 pi over 4. So we can go ahead and label these. And then from here, if you remember the cotangent, you probably don't know your cotangent value. So a decent way to think about them is just remember it's either cosine over sine, right? Or it's, and you know too, if like you have a 0 out here, you're going to have undefined. Like there's a pattern going on here. But to think about these for our cotangent, so we know that it could be cosine over sine. So the cosine of 0, wait, so it's cosine over sine. Yeah, the cosine of 0 is 1, right? And then the sine of 0 is 0. So 1 divided by 0 is undefined. Right? We know that at pi over 4, the cosine and the sine are the same. So it would be 1. We know at pi over 2, the cosine of pi over 2 is 0. The sine of pi over 2 is 1. So 0 over 1. Remember, that's 0. And then negative 1. The negative 1 is because we know that at 3 pi over 4 that they're both going to be radical 2 over 2. Right? We just know that the sine's positive and the cosine's negative. So it's a negative divided by a positive, so that gives us a negative 1. And then here we'll get undefined again. So this one's, I don't know, it's not surprising. This one's kind of easier to graph because the table that we create automatically goes from one vertical asymptote to another vertical asymptote. And then from here, look at that. And let's see, so we're going to end up with something like that. Oops. Did we end up with that sketch there? So again, it still goes up to infinity, down to negative infinity. Our domain, well, we see that we're going to have a bunch of, we know that they're going to, every period we're going to have one vertical asymptote, correct? So we pick the location of 1. I would always pick the location of 0, right? So then it would be like 0 plus pi k, but we could just say pi k. K is contained in the set of integers, and then the range would again be y is contained in the set of real numbers. Here we go. Okay, so a couple examples here. This first one is f of x equals the tangent of pi over 2 times x. Do not put anything in this x column until we know what the period is. We have to know what the period is first. So we said for tangent and cotangent functions, the period is going to be pi divided by pi over 2, right, because that's the b value. So that when you multiply that out, that gives us 2, right? So the period's 2. I think I saw some people that had 4 as their period. So if you did that, be sure to check that because there were some that were incorrect there. So again, and then we're going to go ahead and make our table. So there is no phase shift. So we start at 0, and then we end at 2, and then we have 1, and then we have a half. And you could say 1 1/2. I'm going to say 3 halves. Just tends to be more common. So then with this, now don't just fill in the y column, because I think that's what's happening, and that's how you get completely wrong x values, yet you think you're done, because you just didn't really do any math, I think was the problem. So if we put 0 in here, pi over 2 times 0 is just 0. Right? The tangent of 0 is 0. Good, that worked the way we hoped it did. That one always kind of works the way we hope it does. Now let's put 1/2 in here. Pi over 2 times 1/2 is pi over 4. right? The tangent of pi over 4 is 1. Now, if you have the wrong value here, if you have a 1 or if you have a pi over 4 or if it's anything but 1/2, almost anything but 1/2, you should not be getting 1 there. So it's important to actually evaluate them. That's why we don't graph right away. We actually learn how to evaluate trig functions first, then we use those to graph. So the next one is 1. That gives us the tangent of pi over 2. That's straight up on the unit circle, correct? And that's where it's undefined. So again, at a minimum, you should know the tangent of 0 is 0, the tangent of pi over 4 is 1, and the tangent of pi over 2 is undefined. Right? You don't know the other ones as well. So here we get 3 pi over 2 times pi over 2, which gives us 3 pi over 4, right, which is up in the second quadrant. It's 1 or -1. All students take calculus. It's -1. So -1. Then you put 2 in here, you get the tangent of pi, and that's going to be 0 again. So this is the table you should have. Right? If you're doing it the way we talked about, this is the table that we have. So now to graph this, let's put 1 and -1. So let's see. Here's our vertical asymptote. Here we had 0, 1, -1, 0. So we know that we have to repeat a little bit, correct, to get a full period in here. So this will be up, and this will be a vertical asymptote. This will be down, and this will be a vertical asymptote. So then there and there would be what our graph would look like. So in terms of our domain and range, we see that we have, so let's see, this would be -1/2. This, well, we know the period's 2. I don't know why I always look at the graph to tell what the period is, but we have it written down right there. So that's going to be, we're going to have 2k for the domain. It's going to be a part of it, and then we're just going to start at one of our points. So we could say the domain is x cannot equal 1 plus 2k. Would be fine. Right, because 1, we saw we had a vertical asymptote. K is contained in the set of integers. The range is that y is contained in the set of real values. Okay. That working for us? Good. All right, I want to look at this next one here. This was actually the last one on the paper. It is a cotangent, which is fine. Actually, a little bit easier sometimes. But it has a phase shift, right? We see that x minus pi over 4. So just like we noticed in a sine or a cosine there's a phase shift, we noticed the same thing here. So our phase shift is pi over 4. There's no multiplier on x, so it's just a 1. So the period is pi divided by 1, which is just pi. We know that we start our table at the phase shift. We finish our table at the phase shift plus the period, which would be 5 pi over 4. And then we talk more about how to get the table built when we're doing sine and cosine on those. So, and then here, add those up. You get 6 pi over 4 divided by 2. You get 3 pi over 4. Add those up. You get 4 pi over 4. Cut it in half. It's 2 pi over 4, which is pi over 2. And this would be pi. So we get these values here. So then as we do this, really kind of the big thing to help here is we know that the cotangent of 0 is undefined, correct? And then it goes from there. So if we put pi over 4 in here, we do get the cotangent of 0, which is undefined, right? Undefined plus 3, still undefined, right? You can't define something like that. Okay, so let's put pi over 2 in there, right? Pi over 2 minus pi over 4 is pi over 4. Right? The cotangent of pi over 4 is 1. Right? So we get 1 plus 3 is 4. Okay, we put 3 pi over. 3 pi over 4 minus pi over 4 is 2 pi over 4, which is pi over 2. Right? So the more you work through these, if talking through it just blows your mind, that just means you have to write a little bit. Just grab some scratch paper and do the math. Do that for a few times, and then you'll be able to talk your way through it. Like anything, the more you practice, the better you get. So the cotangent of pi over 2 is 1. I'm sorry, 0. 0. Silly. 0. So 0 plus 3 is 3. And then pi, so let's see, pi minus pi over 4 is 3 pi over 4. The cotangent of 3 pi over 4 is negative 1. Negative 1 plus 3 is 2. And then 5 pi over 4, take away pi over 4 is just pi. And we know the cotangent of pi is undefined. Kind of, hopefully, that's why we put so much emphasis on the trig value quizzes and stuff. It's just to know these is to be able to be successful. So to graph this, I guess I should label this. So here's pi over 4, pi over 2, 3 pi over 4, pi, 5 pi over 4. So vertical asymptote here, vertical asymptote here, and then we have up here at 4, over here at 3, down here at 2. So we're still going to see that same shape we saw before, but because there was a plus 3, the whole thing is just shifted up 3 units. So to graph one period here, it's going to look something like that. Does that work for everybody? So again, to write our domain, we see the period as pi. I'm going to look at where I wrote it down this time, but you could find it from the graph if you needed to. We see at pi over 4 there is one vertical asymptote. So x is not equal to pi over 4 plus pi k, and the range is y is contained in the set of real numbers. So you want to make sure that we're able to sketch some of these pretty comfortably. Okay, this is something we're going to see, you need to know about in the future.